Hey everyone, we've all seen just how high healthcare costs can get. So today, we're going to break down a really cool student project that uses some serious data engineering to find billions, yes, billions, in wasted Medicare spending. A team from San Jose State University built a system to track prescription efficiency, and honestly, what they discovered is pretty eye-opening.
So this all starts with a massive question. As drug costs keep climbing, how can we use data to stop the bleeding? And we're not talking about rounding errors here, we're talking about billions of dollars in taxpayer money. This project actually maps out a way we could start to reclaim it.
All right, so here's our roadmap. First, we'll look at the problem itself. Then, we'll dive into the data solution they came up with and how they built it. After that, we'll explore their custom efficiency metric, check out the key insights they found, and then wrap up with the project's overall impact.
Okay, first up, let's set the stage. We need to understand the problem because that's what makes this whole project so important.
So here's the deal. Prescription drug costs in the US have just gone through the roof. And a huge piece of that puzzle is the choice doctors make between pricey brand name drugs and their much cheaper generic versions. When that more expensive option gets picked for no clear medical reason, it adds up to billions in costs we could have avoided. Costs that we, the taxpayers, end up covering through programs like Medicare.
And you know, the amount of money we could save here is just staggering. Seriously. Research from places like the Congressional Budget Office suggests that if we just use more generics, we could cut these costs anywhere from 20 to, get this, 80%. That is the huge, multi-billion-dollar target this project is aiming for.
So you've got this massive problem. How do you even begin to tackle it? Well, that brings us to section 2, where we'll look at the team's data-driven solution.
Okay, so their game plan had 4 main parts. First, they had to design a data pipeline that could handle a whopping 25 million plus Medicare records. Second, build a clever hybrid data storage system. Third, and this is the real game changer, they needed to invent a new way to score prescribers, which they called the Provider Efficiency Index. And finally, they had to make it all understandable with interactive dashboards.
All right, let's get into the nuts and bolts. Section 3 is all about building that data pipeline. This is where they took a mountain of raw, messy data and turned it into something clean, organized, and actually useful.
So the heart of this whole operation is what's called an ETL pipeline. The best way to think about it is like a digital assembly line for data. The first step, extract, grabs all the raw data. The next step, transform, cleans it all up, gets it organized. And the last step, load, delivers that shiny, clean data into a new storage system where it's ready for analysis.
Okay, so this diagram gives you the 30,000-foot view of the whole system. You've got the raw data coming in from the left, it gets crunched by some Python scripts in the middle, and then it's sent to 2 different storage systems before it comes out as these beautiful, insightful dashboards on the right. Let's break that flow down a little more.
So let's zoom in on that assembly line. Step 1 is extract. They're reading over 25 million records, but they do it in smaller, manageable chunks so the system doesn't get overloaded. Step 2 is transform. This is where the real work happens. Data gets cleaned, names get standardized, new calculations are made. And finally, step 3 is load, where all that cleaned up data gets sent to its new homes.
You know, this next part is actually one of the smartest things they did. They used 2 different kinds of databases for 2 different jobs. For flexible questions about, say, one specific doctor, they used a NoSQL database called MongoDB. But for huge, big-picture analysis across millions of records, they used a SQL data warehouse called Neon. It's all about using the right tool for the right job, and they absolutely nailed it here.
All right, so all that data crunching, all that processing, it was all leading up to this, the project's big, innovative idea in Section 4, creating a new way to actually measure success.
They came up with a new metric called the Provider Efficiency Index, or PEI for short. The concept is simple but really powerful. Boil everything down to a single score between 0 and 1 that shows how cost-effective a doctor is. The closer you are to 1, the more efficient you are. You're using generics and keeping costs down.
So you're probably wondering, how do they actually calculate this score? Well, it's not just one thing. It's actually a composite score made up of 3 different pieces that are weighted differently: a generic score, a cost score, and a volume score. Each one tells a part of the story.
And this table here, this is really the secret sauce. You can see that the generic score, basically the percentage of drugs prescribed that are generic, is by far the most important factor. It's weighted at 60%. That means prioritizing generics has the biggest impact on a provider's score.
Cost makes up another 30%, and then a small 10% is tied to volume, which is kind of a stand-in for experience.
Okay, so we've got the pipeline, we've got the efficiency metric. Now it's time for the payoff. Section 5. What did all this work actually uncover?
So you look at the main dashboard, and the first thing you see is kind of surprising. The median provider efficiency score is 0.90, which is really high, and the average rate of prescribing generic drugs is 99%. So at first glance, it looks like most providers are already doing a fantastic job.
But, and this is a big but, here's where the story gets really interesting. On the left, you can see that, yeah, providers in primary care are super efficient. But then you look at the chart on the right, and it tells a different story. The states with the highest total costs are California, Texas, and New York, mainly because they have the most people. This creates a fascinating conflict. You can have very efficient doctors but still have incredibly high overall spending.
So let's boil it down to the key takeaways. Overall efficiency is actually pretty high, especially in primary care. But here's the kicker. The biggest opportunities to save money might not be with the least efficient doctors, but rather in the states that just have the highest spending overall. This is exactly the kind of insight that policymakers can actually use.
All right, let's wrap this up by talking about the real-world impact and what could be next for a project like this. You know, it's worth pointing out that this wasn't just some messy student project. They ran this thing like a professional software team. They used agile methods, managed their work on Trello, used GitHub for collaboration, and even did pair programming for the really complex stuff. That professional approach is why the final system is so solid.
So what's the bottom line here? The impact is that this system takes public data and turns it into a powerful tool that policymakers can use to make smarter decisions. And they're not stopping there. They're already looking at what's next, adding more years of data to spot trends, maybe using machine learning to predict efficiency, and even fully automating the whole pipeline. The potential here is just enormous.
When you step back and look at it, this project is just a fantastic proof of concept. It really shows how smart, thoughtful data engineering can take these massive, complicated public data sets and turn them into clear, actionable intelligence. It gives us a real framework for making our healthcare system just a little bit better, one data point at a time.